Hi all. This time I'm gonna show you how to make a digital analog converter. We're going from pulse width modulation to analog voltage 0 to 10 volt. It is needed for controlling here, let's say here as you see here the spindle of a CNC. Here is Linux CNC running, and I have here a slider to take the voltage out and off. Here you see the pulse width is modulated by the RPM. This is the output of the brick here we make of the electronic circuit. Here go up and go down. It's a 5 volt. It goes inside here of a RPM controller that has 25 ampere DC. You can also have a multiple kilowatt VFD. It will take here 10 volt. This here is only 5 voltage. So where does the volt? As you see here on the second amp meter, here it's a voltmeter. It's the voltage that goes to the spindle. I will now go up from, maybe you can see, to 20,000. And here we have a max of 17 volt, as the spindle is rated 18 volt max. And out of the 5 volt input from the controller we can get 4.3 voltage to the electrical circuit. So what it's made for, or better made of, I have here a 4011 2 input NAND gate, and as I said here we have 5 plugs. On this side here it's the 12 volt in. Here in this case we have only 5 volt in. Then the second is the output that goes, it's the yellow cable that goes to the actually spindle control or control point, whatever you need. And we have 2 minus, 2 grounds. Of course we need one for the VFD and one for the controller board. Here it's the controller board is one, it's only one PSU here inside, so it's all one piece. And so we have, let's do a little here clear up. I will show the brick itself. Here the electronic board. This is the 5 volt in. The yellow cable is the output, 0 to 5 volt. Here the white one comes from pin number 16, is the pulse width modulation, and the black one is of course ground. So here are the condensers and only a few, and one transistor, few resistors. Let's go to the schematic here. As I said, let's start over here. This is the main capacitor, the main voltage stabilizer, if you get it that way. You can use 470 microfarad if you want. UF or 100 is okay. Then we have the NAND gate here, 10 kilo ohm for the input to the NAND gate itself. It's bricked as you see. Then we have I'm in Germany, so Europe, we have a transistor. I use BC337 for this one, and we have an overshoot here for, it's also 10 kilo ohm overshoot for the output. The output is bricked here. Here's the output, comes to 1 kilo ohm, goes into a capacitor for 5 volt. In the system here it's 22 UF microfarad, and with 12 volt usually it's 10 microfarad UF. So I have also here a LED inside to show me what if the brick, the electronic is on power. It's a 2 milliampere 5 volt LED, and it's run through a 1.5 kilo ohm resistor. So it's a small thing, you can build it your own and it works perfect. Here, let's show up once more the slider where we are here. As you see, yeah, you can also hear, goes up and down, and here we are with the voltage. The max is 4.3 out of 5. Therefore, usually it's input 12 volt here from the VFD that comes in the real machine. I have only 5 volt in, and I only can get 4.3 out. So it's not 100% machine system. Okay, that's it for today. I hope I can help you. If you need help, join us on the IRC. It's an internet relay chat. It's just a text message program on the Freenode server. The channel is Linux CNC, and we will help you if you need help. Bye, to the next time.